Now, one thing about acids and bases is that they neutralize each other. Acid neutralizes base to form water. So I happen to have a beaker filled with water. Now, the way I can tell it's water, I have the indicator, universal indicator. I'm going to put a few drops in here, and it turns kind of a greenish color. So this is neutral water with a pH of roughly 7. Okay, probably a little off because it's tap water. So now I happen to have over here, I happen to have sodium hydroxide. So this is sodium hydroxide, so I'm going to add a little bit of universal indicator that you can kind of see it's kind of a blue color for the universal indicator. And on this side I happen to have nitric acid, which is here. I'm going to add a similar kind of thing. Notice it turns it red. All right. Now, one thing to note about these two beakers of the acid and the base is I actually have, the acid is twice as concentrated as is the base. So if I have a stoichiometric ratio, if I pour them together, they should neutralize and form neutral water. So I'm going to pour them together. I'll pour the red and the acid into the base. So if I do that, it should turn to the same color. We'll see if I'm right. Yeah, it's still a little bit blue, so not quite. It's really important to try and get it just the right. So, Mr. Sams probably needs more acid in here.
Yeah, it looks like it to neutralize it.
So I'm going to throw a little more acid into this, and I should eventually...
Yeah, I didn't measure these real accurately. I just kind of threw them in there.
Now it's got... Yeah, well, you can get it probably just...
Oh!
Now, what did I just do, Mr. Sams?
You went too far, yeah.
That's too acidic, so now I'm going to add some more base.
So this is called the rough way to neutralize things.
And guess what? We just ran out of base. I added too much acid. But if I were to, I could neutralize it if I ran out of sodium hydroxide. If I were to continue to add it, I could get it to the green color if I didn't run out of base. But you can kind of go back and forth. And it was neutralized, but then I sort of unneutralized it by adding too much of the more concentrated nitric acid. That's pretty cool, Mr. Sams.
Those colors are so beautiful. What?
They're beautiful.
It was pretty.
They're neutralizing.
They were.
Yeah, they neutralize things. So neutralization, you put an acid with the base and it neutralizes itself.
Yep.
Now, you got to be careful. I mean, if you make it exactly right, you can like mix them together and drink it. But if you make one mistake, then you're drinking
hydrochloric acid or sodium hydroxide or whatever else. Yeah,
that would not
you don't
be
want to
good.
drink.
So hey, what is a neutralization reaction? A short podcast here.
Yeah.
All right, hold on. There we go. All right. What is the definition of a neutralization reaction?
A neutralization is when you mix equal numbers of moles of acid.
Equal moles.
And a base.
Of acid with equal moles of base.
Yeah, and what you're going to end up with is water and salt water.
Yeah, so you're going to end up with, well, what do you mean by salt water? You're going to end up with water plus
the
A salt.
A salt, right.
A lot of people get confused with salt, thinking sodium chloride.
Right, not so necessarily. You can make sodium chloride in water, but not necessarily.
So here's the general example. An acid plus a base will make water plus A salt.
Right. Some sort of ionic compound.
Yeah.
Basically, what you're going to get, you're going to get, that was dumb, wasn't it?
Basically, yeah.
Sorry. You're going to get the cation from the base combining with the anion from the acid.
Yeah.
And
the definition of the word salt, by the way, is an ionic compound.
It is.
For all intents and purposes. So let's do some specific examples.
Okay.
So let's say I have...
Let's do the one we did in the video.
Which was HCl.
HCl and
NaOH.
sodium hydroxide, right. So now, guys, these are all double replacement reactions. We've talked about these in Unit 4.
Yeah.
And so the H goes with the OH to make water, HOH.
It's actually best to write water as HOH because when you balance it, it's easier.
Yep.
And then the sodium is going to get together with the chloride. Now you have to play the charge game. Sodium has a charge of +1 and chloride has a charge of -1, so that's just simply NaCl. And that balances. So that's pretty easy. But let's do one that's got a little more charge interest. Okay. So let's take H3PO4, phosphoric acid, and let's react it with
KOH.
KOH. Co. All right. So that's going to make water. It's neutralization.
Yep.
HOH. Ho. Okay. And then potassium is going to get together with the phosphate. So we got to play the charge game. K has a charge, +1. Phosphate, PO4. Look on the back of your periodic table.
-3.
-3. Charges don't add up to 0, Sam.
Nope.
I need 3 potassium.
Yes, you do.
K3PO4.
Now we got to balance the equation.
Put a line in front of each.
All right, who's the most complex? Oh, looks like the potassium phosphate is. He's got 3 of them, so I'm gonna put a 1 there. I gotta go back here. I gotta fix my potassium, so put a 3 here. All right, that gives me 3 OHs. That's the 3 OHs here.
Yeah,
so I put a 3, and that gives me 3 H's. Hey,
there's 3 H's there.
3 H's there.
Now, one thing we should mention here: acids have acidic properties. Bases have basic properties.
Correct.
And when you mix them together in equal quantities, you no longer have acid properties. You no longer have base properties because the thing that made it an acid and the thing that made it a base, they smushed together to make water. And water is neutral, which is why these are called neutralization reactions.
Well, that makes sense, Mr. Sims.
It does.
You make sense today. What's
Thank
up
you.
with that?
You know, it's the
You were
afternoon.
sour earlier, and now you're
I had
like
some
making
coffee.
sense.
My back's feeling better. I got this nifty new chair.
Let's do another one. How about H3PO3?
PO4.
No,
3.
PO3.
Oh, there's a 3.
Phosphorus
Hey, look,
acid.
it's a 3 there on the.
I know. And let's react that with calcium hydroxide.
All right, that's a good one. This should be fun.
This is the 6 guy.
All right.
All right. So hey,
Water.
Water.
HOH.
Huh. Plus, all right, calcium.
Okay. Calcium has +2 charge.
Phosphite. Phosphite.
Phosphite. Yes.
Phosphite is -3.
Yep.
Those do not cancel out. I must make a 6.
Yes.
So if I make a 6, I need a 3 of a one and a 2 of the other.
Yeah.
So it's a Ca a 3 and a PO3 a 2.
Wow, now you're like fading into some almost Italian accent.
Yeah, it's a 2.
I think this is new.
Yeah, so
we're
it's a
branching
Ca
out.
a 3, a PO3 a 2, and this is complex one, right
Yes.
here. This is the most complex. So this is the most complex
Yep.
one.
So
guys,
start with the
put a
one that has
here.
most stuff in it.
And so I got a calcium problem. So I'm going to fix the calcium problem by putting a 3 here. That gives me 6 of hydroxides. Now the hydroxides are here, so put a line in front here. That'll give me 6 H's. Now if I come over here and I have 3 H's, so I'm going to put a 2 in front of that. Now that gives me how many phosphites?
2 phosphites.
2 phosphites.
But hey, look, you have 2 right there.
It's done.
Ding.
Guys,
That's it.
that's it.
Pretty simple, huh?
Yeah, just balance equations.
Yep. You've done this before.
And you make water. HOH. What do you make?
HOH.
Bye.